I would like to thank to the organizing committee and the International Program Committee for this opportunity. I will take advantage of my virtual assistants to perform the speech and present to you this work. 2 degrees of freedom control implementation for remote laboratory course in control education. First, I would like to introduce the group that did work in this research.
Danilo Oliveira Martins, PhD student in Systems Engineering at São Paulo University, USP, Brazil.
Gabriel Pereira das Neves, and PhD in Electrical Engineering at São Paulo University, 2021.
Alexandra Brinkelip Campo received PhD degrees in Electrical Engineering from the São Paulo University.
Bruno Angelico, since 2013, he has been with the Telecommunications and Control Engineering Department, EPUSB, where he is currently a professor and the coordinator of the post-graduation program.
Applied Control Laboratory belongs to the Automation and Control Laboratory, LAC, of the Telecommunications and Control Engineering Department, PTC, of the Polytechnic School of the University of São Paulo. It was created in 2016 with the aim of developing research related to practical applications of control theory and building control systems, plants. The activities developed in the laboratory are basically application of control algorithms in practical systems. Many of the control strategies seen in undergraduate courses are limited to theoretical examples. With a real system, the motivation for learning is amplified. Development of control plant prototypes. Good quality teaching equipment is usually very expensive. Thus, one of the laboratory's missions is to develop low-cost prototypes, but with all the functionality of a commercial system. Such prototypes may, in the future, equip the didactic control laboratory at EPUSB. Training of qualified human resources. The laboratory has students with research in the scope of scientific initiation, course conclusion work, master's and doctorate.
This work presents the 2DOF control implementation for a remote laboratory course in control education, integrating an IoT-based framework, IoTControl. The control system development is applied in the practical experiment, a 2DOF helicopter, providing telematics of the control algorithms by the data network management software in an embedded solution to control the plant. The implementation utilizes the framework to provide real-time access for parameters configuration and graphical analysis of the controller. Control systems telematics is relevant for remote laboratories, providing remote access and promoting inclusive education. The implementation consists of an LQR position control using an open-source framework to build the application. The user interaction is provided by the web page hosted in the controller hardware, allowing machine-to-machine communication. It can be accessed by any hardware connected to the network.
The 2DOF helicopter control plant has a 12 volts DC power supply, 2 encoders, being installed at the pitch axis and the other one in the yaw axis. 2 brushless electric motors with electronic speed controllers are also installed, one in the pitch and the other in the yaw axis. The hardware was built by Barbosa et al. In 2016. The framework source code and algorithm with instructions are available in a public repository. From the IoTControl framework, the web pages interface that are specifically created to this experiment was added in the net control module, allowing to the user the controller selection and automatic application control software execution. Considering the control plant modeling presented by Barbosa et al., 2016, the process uses the Lagrangian method. The nonlinear equations of motion are presented. Linearization method is applied for a small region around the equilibrium point. Considering a state space representation. A state feedback controller that minimizes the cost function. Finally, the experiment runs the controller under the app control in the IoTControl framework. The controller software pseudocode is next presented.
The implementation test was executed in the Applied Control Laboratory, LCA, at University of São Paulo.
Thank you for your time and attention. I would like to demonstrate to you the IoTControl implementation using the control plant helicopter 2 degrees of freedom. Let me power up the plant. Okay, and then let me open the web page interface. Okay, here it is. So here we're gonna try the experiment. I'm gonna start the LQR control, and we're gonna keep the plant in the horizontal line. Let's just check. Okay, here is the controller in action. You can try to disturb the plant. Okay, gonna keep the controller. The controller wanna keep the plant in the horizontal line, but we also can change the reference. Let's try. +1 rad. In the yaw axle, let's do -1 rad. Can change the pitch angle. Let's try 0.2 rad. Let's take it back to 0. Okay, let me stop it. And then we can analyze the dynamic behavior of the plant by selecting the graph. Let me zoom and focus. And let me select the graph option for the helicopter. Okay, here's the collected data from the experiment in real time. Okay, student can navigate through the data. So let's capture. Here is when I did apply the disturb. You can see the control effort. Again, the disturb behavior. Here is the startup. So the angle in pitch is below 0. So the controller wanna make the pitch angle to go to 0. You can see that the error in steady state is converging to 0. Let's check the reference change. So here we did change the reference to almost 1 rad positive. And then you can see that they are gonna reflect that set point. Then we turn to -1 rad. You can see that the yaw axle converges to the desired position. That's it. Thanks. Some screenshots of the graphical results of this experiment. As a conclusion, up to now, the paper presented the development and experiment results of the 2 degrees of freedom helicopter control system integrated in the IoTControl framework as a tool to implement the control system in a practical experiment. This technology enables telematics to the control plant, being a key solution for promoting the remote laboratory. More information can be found in the references of this paper. In future work, the proposed experiment can be improved. Other control algorithms can be implemented. We aim to experiment new technologies such as implementing new features for data science techniques to automate the results, analysis, and the control experimentation. Going further, we will implement the remote laboratory network using software-defined networks as the proposed solution for network management of the laboratory's content distribution center. The experiment is reproducible. The source code algorithm with instructions is available in a public repository. I hope you did enjoy this presentation, as I did enjoy to prepare the paper with the results of this research. Thank you so much.